Hi everyone! Imagine this, no internet, no mobile network, no base stations anywhere nearby, but you still need to send a message, your coordinates, a photo, or even a voice note. That's exactly why this autonomous messenger was created, a device that connects directly over radio. Not just a walkie-talkie, and not just short text messages, but a complete communication system for places where there is no communication at all. Text, files, voice, directly between devices. Now let's start with what already works. There are 4 different devices on the table. A message goes into the group chat, and every participant receives it instantly. A specific user can be selected. And then the message arrives only in a private chat. Voice messages work too.
Test system 1, 2, 3.
Test system 1, 2, 3.
A photo can also be sent. It transfers at about 1 kilobyte per second. Yes, that's not fast. Definitely not Telegram. But in a critical situation, even a single photo like this can save a life, especially since the app has automatic image compression before sending. And for real emergencies, there is an SOS button. Press it, and every participant in the network receives a notification with your coordinates. On the map, your position is highlighted with a red marker. So this is not just a toy for chatting without the internet. It is an autonomous communication channel that can work where there are simply no other options. But getting to this point was quite a journey. At first glance, the plan looked as reliable as a Swiss watch. Take something that already works, has open source firmware, and modify it for my own needs. The obvious starting point was Meshtastic, so that's where the firmware digging began. For reference, Meshtastic is an open source mesh network for small radio devices. These devices can exchange short text messages over long distances, without the internet, cellular networks, or base stations. In practice, each device becomes a small network node, and can forward messages through other devices. At first it even started to work, but pretty quickly the main limitation became obvious. Meshtastic is great for short text messages, while this project needed much higher bandwidth. The goal was not only text, but also files, and eventually voice. So the modulation parameters were changed to increase the data rate. As expected, the range dropped significantly. To compensate for that, the transmitter power was pushed higher, and then the modules started dying one after another. 4 of them were destroyed. At that point, it was no longer a coincidence. It was statistics. Their RF path simply could not survive long periods of high-power transmission, so a different route was needed. All the components were ordered separately. An ESP32-S3 controller, a radio module, GPS, antennas, and everything was wired together by hand. A custom test firmware was flashed, and it worked. Practical testing showed that the communication range stayed the same as the basic Meshtastic setup, but the speed increased by 2 times, and that was already usable. Once the theory was confirmed, a custom PCB was designed and sent for manufacturing. The boards were ordered PCB way. This was not the first time using them, and the quality has always been excellent. Everything was assembled and soldered manually, with a soldering iron, solder paste, and flux gel. Overall, it is not too difficult. Maybe using a hot plate would have been the proper way to do it, but working with a soldering iron just feels more familiar. In the end, what matters more is getting a reliable result, not suffering beautifully with the correct tool. The link to the PCB service will be in the description, along with everything else needed to build the device. For example, 5 boards will cost $5. Shipping is the same. You can also order 3D printed cases there at the same price. Handy if you don't want to buy a printer just for a couple of devices. By the way, choosing the antenna unexpectedly turned out to be one of the tricky parts. Most of the antennas bought on Amazon were complete garbage. They were selected by rating and reviews, but out of 10 antennas, only 2 were actually good. The others had such a strong resonance shift that the device simply refused to work properly with them. For example, this is what a regular highly rated Amazon antenna looks like, and this is the one that actually works well. The quality difference is immediately visible. In the end, the best antennas were found on AliExpress, and overall, all the components were much cheaper there. Links to verified sellers will be left in the description. The electronics needed protection, so a case was designed and 3D printed. The board itself was coated with a special protective compound, so it would not be afraid of water. But you know what? Making the hardware was actually the relatively easy part. The hardest part of this project was writing the firmware and software so that everything would work reliably. The code took 3 months of work, with no days off, 10 to 16 hours a day. The mesh network logic was especially painful. Packets had to move between devices without interfering with each other, and any node had to be able to automatically become a signal repeater. But now this feature can multiply the total communication range by building a chain of devices. Voice transmission over this channel was also very difficult to configure. In the end, codec 2 was used, which made it possible to compress voice by 300 times. Only after that did voice transmission become possible. Of course, autonomous communication also has to be secure, so two technologies were added. First, 256-bit data encryption. This makes intercepting and decrypting messages extremely difficult. Second, a closed network. Once all members of your group have gathered, you enter a shared password and close the network. After that, an outsider cannot connect to your network or read the transmitted data. There is also a region selection in the settings to avoid violating local regulations. The device can switch between 868 MHz for Europe and 915 for America. The app also lets you adjust the range and data speed settings directly, depending on the environment you are in. And since this device is made for situations where there is no network, offline maps were a logical addition. There are two options. Either download the needed map area in advance while internet is still available, or download a global map of the entire world. It is not the highest resolution, but in a critical situation, it is much better than nothing. And to turn the app into a real Swiss Army knife, an AI assistant was added. The local neural network works even on basic phones without internet, and can help with simple reference questions. For example, how to purify water, or what to do in difficult conditions. It is a small model, but that was intentional. AI is developing very quickly, so the app also includes the ability to load other language models of your choice. And just to show the full scale of the work, custom apps were written for 4 different operating systems: Mac, iOS, Android, and Windows. Now field tests. In a city park, with direct line of sight, the range reached 700 meters. The park was small, so the next test was done in a park on the outskirts of the city. It looked more like a forest, and there the range was a solid 500 meters. But once the device was taken up a hill, the signal reached 1,500 meters. It probably could have gone even farther, but the park simply ended. In dense urban conditions, with a residential building standing between the modules, the range was 300 meters. Then, a third module was enabled as a repeater to test the mesh network, and another 450 meters were added. The network works great. The device is already fully functional. You are probably wondering, can you use this yourself? Yes, the project is fully open source, and it is already available on GitHub. And if you want to support the development and build the device without the headache, the project is live on Kickstarter. As a reward, you will receive a complete DIY kit, a very detailed video guide for assembly and flashing, 3D models for printing the case, Gerber files for ordering PCBs from a factory, and a user manual. The Kickstarter link is waiting for you in the description. Thank you very much for watching.